Hi guys, it's Mr. Brian here. In this video, I'm partnering with EduKaji to guide you on the SPM 2025 physics paper, and we'll be discussing paper 2 today. Okay, without further ado, let's get started. So your 2.5-hour paper, we go straight into question number 1. Quantum physics. Photoelectric effect, straight away. Okay, diagram 1 shows a light beam with a certain frequency is illuminated on a metal surface. Particle Y is emitted from the metal surface due to photoelectric effect. State the particle Y. Usually, photoelectric effect is a pretty popular topic. Now, as long as you know the whole concept is you shine some light onto a metal surface and electrons get emitted, you're good. Usually they just need you to know this. That's the minimum, the bare minimum. So particle Y is what we call as an electron. Okay, you can also say it is a photoelectron. That is even more accurate. Guys, please know that they are the same thing. Photoelectron is just an electron that comes out because you go and shine some light. Photo means light. Okay, and then part B, state one characteristics of the frequency of light beam that enables the photoelectric effect to occur. Okay, there is something called threshold frequency that you need to know. If you want to shine a light, and you want electrons to come out, you cannot just shine any kind of light. The light frequency, the frequency of the light must be higher than the threshold frequency for that piece of metal. So different metal will have a different value. You must make sure you are higher than this value, called threshold frequency, then only electrons will be emitted. So you just want to write this out in words. Frequency of light higher than threshold. Okay, so that photoelectric effect can occur. Frequency of light beam is actually equal also can. Is equals to or higher than the threshold frequency of the metal. Is it okay if you never say is equals to, you just say is higher than? Is it fine? Yes, it is also fine. So I put in bracket optional. If you just say frequency of light beam is higher than, can also, as long as you achieve it. So that's the minimum value. It can be equals to also. Okay, then part C1, what is the change to the intensity of light beam that will cause milliammeter reading to increase? If you want current to increase, the intensity must increase. Okay, so what should you do to the intensity? You should increase it. Increase the intensity of light. Can I just say increase? Can. You don't have to write the whole thing also can. If you just say increase, also already correct. Okay, then they ask what is the reason? How come when you increase the intensity, then the emitter reading will increase? Well, that is because intensity is the brightness. Imagine if you have one photon, you go and shine on a piece of metal, then maybe you will only have one electron emitted. But what if I have triple the light photon? Triple the, this is what we mean by increase the intensity. You make it brighter. Triple times the intensity, let's say. Then maybe I can emit triple the electrons. This is what we mean by increasing the intensity. You shine a brighter light, there'll be more photon. Let's say I got triple the amount of photon, I'll have triple the amount of electrons. More electron flowing means more current, right? So the reason is because when intensity increase, more photo electrons will be emitted. More photo electrons, or you can just say electrons are emitted from the metal surface. The word photo is optional. more electrons come out. That's why current increase. That's why ammeter reading will increase. Okay, and question 1. Question 2. Light and optics. Diagram 2 shows a stem collector using a magnifying glass. Okay, magnifying glass to observe his favorite stem. The distance between the lens and the stem is less than the focal length. Lens and stem. Stem is your object. Okay, stem is your object. The lens to your object is what you call as object distance, which has a symbol of U, and the U is less than the focal length, F. So they're trying to say in this sentence, the U is shorter than F. Okay, state the type of lens used for magnifying glass. Magnifying glass must be convex lens. Convex also got another name called converging lens. Okay, why converging? Because convex lens look like this. When light enter, because of the shape, it will bend, it will refract the light so that it converges. So that it converge means so that it focus like that. So this is what we mean by converge. This is a convex lens. Okay. The stem collector discovered that the size of the observed stem is bigger. The image size is bigger. State 2 other characteristics observed by the stem collector. Some people feel that, hey teacher, this kind of question I'm not very good because maybe I never memorized the characteristics. But you don't have to, because for a magnifying glass, you think if I'm looking at a stem through a magnifying glass, other than, of course, the image will be big, because magnifying glass, of course, the image will be big. What else? It must be upright. Agree or not? It must be upright. When I look at a magnifying glass image, it will not be terbalik one. It will be upright. So it must be upright also. And then it is also virtual, because virtual and upright always together one when you look at one lens. Real and inverted also always together one. The answer is that it is virtual and also upright. Or you can say virtual and upright. Okay, you get 2 marks there, just like that. Yeah, so magnifying glass, one important thing is you must put your object closer than focal length, number 1. That will ensure that your image will be big, and also it will be upright, so that whatever you see will not be terbalik. It will be upright. By the way, virtual just means that your object is here right now. The image will also be formed on the same side of the lens. Virtual does not mean you cannot see. You can still see a virtual image. It's just that virtual just means that for a lens, it will form on the same side as the object. That's it only. But it will be bigger. Okay? Then part C, the distance between lens and the stem is 5 cm. Focal length is 10. This is what we call as the U. Lens and stem, this is the object distance. Focal length, that is F. Image distance is V. There is a formula. This was the stuff that I did for paper 1. Okay, there is a formula that you can use, which is this one. Okay, 1 over F equals 1 over U plus 1 over V. This is your thin lens formula. It's 1 over F first. Sometimes I'll write 1 over U plus 1 over V equals to 1 over F. Or if you want to follow exactly, you can write 1 over F. It doesn't matter which side is first. Okay, let's say I just follow exactly. Now, the formula is simple. The calculation is simple. Just that, I just want to remind you guys, for thin lens formula, you have to be careful. Some of the things can be negative one. Okay, some of the things can be negative one. Like the U is positive 5. Okay, why? Because object distance is always positive, by the way. Object is always at the correct side, so object is always positive. Focal length, it depends on what kind of lens. If you use a convex lens, it is positive. If you use a concave lens, then it is negative. Convex lens. If it's concave lens, then the F is equals to negative value. Okay, And then the image distance, sometimes you need to put a plus or a minus. Image distance, it would be a positive V value when it is a real image. Okay, you will get a negative V value when it's a virtual image. Yep. So the F is 1/10, the U value is 5, everything is positive, and then I want to find V. So what we do is we take this minus, okay, and then let's see what we get. I get negative 1/10. And guys, the fraction you can terbalik, so V is equals to -10. You must leave the negative sign there. Leave the negative sign there. Then only correct. If you remove the negative sign, then it's wrong already. Okay, so you get your mark here and it can. Quite straightforward. This light question is pretty simple actually. They could have asked much more difficult ones. Yeah. Okay, question 3. Diagram 3.1 shows a man clinging on to 2 ropes tied to a bar. The weight of the man is 600 newtons, supported by the rope tension T on each rope. Okay, so this is 600 newton. X and Y are the horizontal axis and vertical axis. Okay. The man is in equilibrium of forces. State the meaning of equilibrium of forces. Equilibrium meaning no resultant force. All the force acting on this guy is balanced, is equal. You can say resultant force acting on an object is 0. Resultant force is 0. Or you just straight up say 0 resultant force. Can, up to you. Resultant force is 0. Or it is 0 resultant force. Or net force is 0. Can. In SPM, we see resultant force is 0. Already got marked. Okay. Part B, on the diagram, draw the direction of tensions acting on the man. Okay. Acting on the man. So now your tension is on the rope, but the whole tension is connected one. Okay, some people will ask, teacher, how do I know whether the tension is pointing up or down? It must be up. In this case, you know why? You must have a tension that is able to support the weight. Weight is pointing down. The job of this rope right now is to pull the man up so that he don't fall down. So the tension is upwards. Now you might ask, teacher, does it mean that the tension in the opposite direction does not exist? I thought we are pulling the rope. You pull the rope in both ways. Yes, there is another tension that is this way, but we only focus on what is helping the man support the weight, the tension that is on the man. Yeah, so if we just focus on the man itself, not on the rope, on the man itself, then we would focus on this particular tension that is pulling him up. Okay, so when they ask you to draw, you draw like this. I'm going to copy and paste. Yeah, or maybe I draw nicer a little bit. But the point is I don't want to change too much. Like just now I drew like this. Yeah, I want to follow this rope. I don't want to change it too much. So when I draw, right, I try to copy and paste. Okay, I try to copy and paste. And then another one also the same. I take my ruler. The rope is like this. I try to copy and paste. Okay, we call this the tension. Yeah, you can go and label also lah, the 30 degrees. How do we know 30 degrees is there? You can use your alternate angles, Z shape. So whatever angle you know, if you know, you go and label. Yeah, for all the drawings is like that. If you know the angle, you go and label. Teacher, do I need to use protractor and measure 30 degree exactly? Don't need. Yeah, don't need. Okay, don't need. Just got the T and also the angle, good enough. If you know the angle, please put it down in any drawings. Okay, that 2 marks. Then calculate the tension on the man's arm, 3 marks. Okay, so this part got many ways. By the way, the weight is 600 newtons. Okay, I write here just so that easy for me to do the calculation. Now, they ask you to draw like this is to help you so that you can use something called the T-shape method. Like in my class, normally I tell my students you can do a method called T-shape method, where you split all the forces into a T shape. Okay, you split all the forces into a T shape. Right now the weight is pointing down. The tension is saying it like that. But I can say this tension, right, is able, I can split it up into 2 components, 2 parts. And this is called T sine 30. This is called T cos 30. Okay, T sine 30, T cos 30. If you are thinking, teacher, how you know it's cos or sine? Oh, that's because cos means closer to 30. Sine means away from 30. Where's 30 degrees? 30 degrees right here. Do you see the tension need to go closer to the 30 degree? The 30 degree is right here and you're getting closer to it. So if you split it up, become like that, it is T cos 30. Now, if the T come down here, 30 degrees right here, do you see the tension has to go away from the 30 degree? 30 is right here and you're going further, 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 further away. 30 is here and you're running away from the 30, therefore this is called T sine 30. Yeah. This works for the other side. This again is T cos 30. This is T sine 30. In an equilibrium case, when we do a T-shaped method, we would always say that any forces pointing up, all the forces pointing up, must be equals to all the forces pointing down, so that it is in equilibrium. Also, all the forces pointing to the left must be equals to all the forces pointing to the right. Okay, that's why you see the left side and the right side, they are equal. Both also T sine 30. Now with that, we can say, all right, all the forces pointing up equals to all the forces pointing down. What are the forces pointing up? T cos 30, T cos 30, there's 2. You can add T cos 30 plus T cos 30. Or straight away, you want to say, I have 2 times of the T cos 30. Can also. Must be equals to the force pointing down, which is the weight, the W, 600. Yeah, how you can write either one of the step. Here also can or here also can. Now to find T, you take 600 divide by the 2 and divide by the cos 30. Okay, so either this step or this step you can start. Straight away you will get 2 marks already. The 2 marks come from where? 1 mark comes from you able to form an equation, a correct equation. A second mark comes from you knowing how to split your force into cos or sine. Okay, because you know how to do your cos and sine, you know how to write all this correctly, you get another mark. And then the final answer, you get 1 more mark. So I'm going to type this in the calculator. I get 346.410 newtons. Okay, that is the answer. Now, some people will say, teacher, what if I label? Okay, I don't know if anyone would do the label like this, like you go and say, teacher, what if I do here 60 degree? Or just now, when I label that time, right, I go and label there 60 degrees. Can or not? Can also. But usually, question give 30, right? We try our best to also put 30. We try our best to use the same values. You might need to move the 30 using the alternate angles, using the Z shape, alternate angles, because these 2 parallel lines. but we try to use back the same values. Usually the mark scheme will use back the same values, if possible. Okay. So if anyone use 60, is also correct. Just that here it would be T cos 60. Tension T go closer to 60, T cos 60. Okay, and up here it would be T sine 60. Tension go away from 60 degrees. Yeah, same thing here, lor. This would be T sine 60. This would be T cos 60. Okay, so when you do your working, the force pointing up is 2 times of the T sine 60, and the weight pointing down is 600. And you you are still going to get the same answer. Just now, what did we get? 346.410 Newton. Both way also works. You do like that. Also, you get full mark. Okay, either one. Okay, there is a third method, but before that, I also want to highlight one more thing. I hope you guys are good at this. Please make sure you know that when you split the forces and all, okay, I rub this off. Don't make it too confusing. When you go and split the force and all, after you split, you don't need to look at this purple color one anymore. The purple color force that you split already become that two components, already become that two parts. This two is the same as that purple color tension. They are the same thing. Okay, there's a third method, which is the triangle method, where you have to draw a triangle. I feel that that method is more troublesome. Now, the method works like this. You are going to have to draw a triangle using all the three forces that you see. Okay, number one, you have a W pointing down. So let's start with that. Number two, you have a tension pointing this way. Maybe I continue like this. And then number three, you have another tension pointing this way. So you continue like that. And this is the triangle that you get, but you're not done. When you do this triangle, you also need to learn how to move your angles. So watch carefully. We have a 30 degree right here. Okay, the 30 degrees right here. When I move this 30 degree, it will come over to here. Can you see? When you copy and paste over, the 30 degree comes over here. So this is 30. But this is when it gets tricky. This is a 30 degree. When I copy this tension and I paste it over, I get the 30 degree right here. Copy, paste. This is where I get the 30 degree. 30 degrees right here. A lot of the time, when the angle is at a very unuseful place, not very useful place, this 30 degree can also come over here. How do I know? Because this is a Z shape. An alternate angle again. Parallel line, this angle, same. Knowing 30 here, this angle is 180 minus 30, I get 120. What is the weight again? 600 newtons. How to find the tension? I can do something called sine rule. The T and the 30 is one pair. The 600 and the 120 is one pair. You can do like this. T over sine 30 equals the force divided by sine 30. Sine rule at maths. 600 over sine 120. Find the T. I assure you will get the same answer. Let me double check. 346.410 Newton. Exactly the same answer. So up to you. You can do what I call as, this is what the name that I call, your teachers normally don't call it like that, but I call it the T-shape method, because you split it into T, and then anything point up and down must be equal, Anything point left and right must be equal, cause equilibrium. Okay, you get this answer. Another method, you have to draw the triangle. Must draw first, you must use the 3 force to draw, and then use sine rule to solve. But you must know all the angles inside first. Okay, up to you which one you want to do. Of course, the light blue one is the most straightforward. Okay, question number 4. Diagram 4 shows the use of ultrasonic wave in the technology of ultrasonic reflection, sonar. Sonar actually stands for sound navigation and ranging. Okay, I use sound to navigate and to find the range of distance of things. Sound navigation and ranging to detect the position of fish in the sea. Okay, state the type of wave for ultrasonic wave. Many people forget that ultrasonic is actually sound wave. Yeah, to be specific, it is called ultrasound. Same thing. Yeah, it is called ultrasonic ultrasound. Ultrasound must be, any sound must be a longitudinal wave. This is the best answer. Okay, you guys know we have longitudinal and transverse wave. Longitudinal only got one example, sound. Transverse got a lot of different other examples. Yeah, but longitudinal only one. Any kind of sound wave is longitudinal. Okay, but if you want, you can also say mechanical wave, because sound wave needs a medium. Mechanical means you need a medium to travel. You need air for sound to travel. You need water for the sound to travel. Yeah, and you can also say progressive. If you write progressive, also they mark correct. Please just write one that you are most confident. Can. But B, on diagram 4, draw the wavefront of the ultrasonic wave that is reflected by the fish to the ship. Okay, so you draw as it hits the fish, what will happen? It will bounce back, it will reflect back. In SPM, you can use pencil to draw lah. So it will hit the fish, and then after that, it will reflect back. Okay, why is it so ugly? Something like that. Okay, something like that. Just draw a few will do. It doesn't have to be exactly centered to here. But one thing you have to be careful is that the wavelength needs to be the same. The wavelength needs to be the same because reflection does not change the wavelength of a wave. Meaning this gap and this gap must be similar. If you do like too close, like that, or too far, then you will lose 1 mark. Okay, then you will lose 1 mark. So how to get 2 marks? Minimum have 2 wave that is the correct shape. If the wave go down curve, it will come back up also curve one. Okay, number 2, must make sure the wavelength is the same. Similar wavelength. Okay, just use pencil to draw. Okay, but see, state 1 characteristics of why ultrasound is used in sonar technology. Give 1 reason why is it suitable. The thing about ultrasound is that it is very high frequency. So ultra is what? Ultra is very high frequency. Ultrasound is higher than 20,000 hertz. Yeah, the frequency is higher than 20,000 hertz. Because it is so high frequency, that's why it has very high energy. It can travel very far. It has high penetrating power. Those are the reasons. Okay, so they just ask for 1 characteristic, 1 reason. I feel the best is because it has high frequency. If you want, you can also say the characteristics is because it has high energy. Also can. So up to you. If you write high energy already, then the reason you cannot write high energy anymore. No? Okay, the reason is high energy. Right? Maybe I should write like a nice sentence lah. If you want to, you can say like, but this is the keyword. I see high frequency, high energy. Actually, you already get 2 marks. right? If I put it nicely, it can sound something like this. Ultrasonic waves have high frequency. Then the reason of why it is suitable. Ultrasonic waves have high frequency. You can continue actually. So it has high energy. You can write like that. It doesn't have to be two sentences. You can write one line like that. You will get 2 marks. Okay? Or you want to say, teacher, the reason can I don't want to say high energy? Can I say, so it has high penetrating power? I can also. Okay? Or can I say so that it can travel very far, can penetrate very far, can propagate very far? Can also. Can propagate further. You can say can travel further, also accepted. It would be because it has so high energy. By the way, a very high frequency wave has a very short wavelength. If you want, you can also say ultrasonic wave has a short wavelength. Okay, and we know anything that is short wavelength won't be diffracted a lot. So it is less diffracted. Maybe. Okay, so got so many possible ways you can write it. Why less diffracted is a good thing for reflection? Diffraction happens when a wave is weaker. When, by the way, diffraction means spreading, spreading of wave. Now imagine if the wave spread a lot, diffract a lot. If it spread and diffract a lot, it becomes too weak and it cannot go back to the transducer. You want a wave that is very strong, can propagate, can penetrate very far, and then come back also very strong. You don't want it to become very weak and spread to the side like that. Straight down, straight up. Ultrasound can do that because it is very strong, very high frequency, very high energy. Yeah, so you can use all these words lah. How you write your sentence, how you write your points, actually not so important. Yeah, not so important. We see keywords, actually we already award you the marks. Okay. Part D, the speed of ultrasound transmitted by the transducer into the sea is this. This is the speed of sound. The time interval between transmission and reception of the sound by the transducer is this. Calculate the distance. To find distance, normally we say distance is speed times time. However, because okay, maybe I draw here will be easier. Because for reflection, the time you will notice, they always give you the time between transmission. Transmission meaning the time when you send, and reception is when you receive. Okay, so you're going to send some wave, and then you're going to receive back this wave. They say the total time to go to the fish and come back is 0.1 second. So therefore, normally for reflection, they will give this time. They'll give the total time to go and come back. That's why it's not just speed times time. The time you need to divide by 2. Okay, so that's why we use this formula. Distance is speed times time, but the time we will go and divide by 2. How come? Because the time is the total time to go and come back, but now I only want the distance, okay, or the distance small letter d like this. Can So answer is 1005 multiplied by 0.1, just that the time I need to divide by 2. Okay, then you get the answer already. Actually, they are quite generous with this one, is 3 marks. Because this formula is not given. But if you think of it, it is just distance or speed formula. Speed equals distance over time, and you just rearrange. Distance is speed times time. But the time you need to divide by 2. Okay, knowing how to divide by 2 is why it is worth quite a lot of marks. Yeah. Then part E, state one application of ultrasonic reflection in the medical field. We use ultrasound to scan the fetus, to scan the baby in the mother's womb. We can use ultrasound to scan like muscle or like internal organ also. Yeah. Anything that can see underneath lah. It's kind of like a little brother of X-ray. Yeah, X-ray is very, very clear and all, but ultrasound is like a not so clear one. And of course, ultrasound, because X-ray is very high energy. You cannot use X-ray for baby, because got radiation and all. Yeah. But ultrasound, okay, it's just sound. Okay. You can say like we use to scan, to detect, to examine tissues in the body. Okay, or you can scan internal organs. You can scan the fetus in the mother's womb. The word scan can use any other words like examine, detect, many different words. I can also use ultrasound to detect kidney stones. Got many things, like anything that is logical will be accepted. Okay, to detect kidney stone, or to image the internal organs, things like that. Yeah, many different answers. You just write one would do, one application. Don't need to write so many. Yeah. Okay. Question number 5. This one is electronics, a transistor circuit. Okay. Diagram 5.1 and 5.2 shows the transistor circuit to function as a light control switch. The circuit consists of resistor P that changes its resistance with light intensity, and also fixed resistors Q and R. Okay. The bulb in the circuit lights up during daytime and does not light up during nighttime. The microammeter and milliammeter measures the base current and collector current. All right. State the name of resistor P. P is what we call as a light dependent resistor, a LDR. A light dependent resistor. If you spell dependent as D-E-N-T, is also fine. It's just American spelling or UK spelling. Yeah, light dependent resistor. Teacher, what if I forget the full name? Can I just write LDR? Yes, you can. In SPM, they allow it. Okay, in SPM, they allow it, right? Part B. Based on diagram 5.1 and 5.2, compare the resistance of P. Okay, the resistance of P. Actually, this is a very good question because I feel normally for if you go and look at comparison question, it's very straightforward one. Yeah, it's very straightforward. But this one, the resistance of P, they didn't give. Yeah, you have to know a little bit about LDR. Okay, so they say the bulb is going to light up. By the way, later on, they will ask you to compare the base current and collector current also. Huh? Okay. And then this one got base current flowing. This one no base current flow. And then this one got collector current flow. This one no collector current flow, the IC. Also, they ask you about what do you think is the resistance of P in the first diagram, the second diagram. Okay. The reason why bulb will light up is because base current flow. It's because collector current flow. That's why bulb will light up. For base current to flow, it means that this guy has a resistance that increased and hence the voltage increased. That's why the whole thing will light up. Okay. The reason why this whole thing doesn't light up is because the resistance for this guy is lower and the base voltage here is lower. Therefore, there's no base current, no collector current, bulb also don't light up. So that's why I always tell my students, when you want you want the whole circuit to work, you must always make sure the base is the one underneath here. Base is always down here. The base must have a high enough voltage. If the voltage not high enough, it will not light up, it will not turn on the whole thing. Okay. Also, I always say that when it's daytime, or rather I tell my students this usually, when it's hot day and when it's cold night, your resistance will be affected. Your resistance for LDR and thermistor will be affected. Hot day, the resistance will decrease. Cold night, your resistance will increase. Hot and cold is for what? Is for thermistor, of course. Day and night time is for what? Is for LDR, of course. Okay, so there's many ways that you can see how to get the resistance of P. Yeah, there's many ways. One way is here the resistance is high, the base voltage is high. That is because here the resistance is low. Sorry, not the base. Here's not base. The voltage here is low. Up here low, down here will be higher. Why? Because 6 volts will share between these two resistors. Okay, the whole idea of a transistor circuit is the battery 6 volt will always share between the two resistors. Maybe here 3 volt, for example. Or maybe here 2 volt, 4 volt. Or maybe here 1 volt, 5 volt. Right? It will share. The 6 volt will share because this is a series circuit. In series circuit, voltage will share. Yeah, we call this a potential divider circuit. So I know in this one simple comparison question, I'm trying to teach a lot of things just in case anyone don't understand how it all works. But you need to have all this knowledge to be able to answer this question. Or straight up, you can just say, oh, teacher, during daytime, the LDR resistance will be low. That I already know it's going to be low. Daytime, it will be low. Nighttime, the LDR resistance will be high one. Nighttime, LDR resistance will be high. Resistance here high, voltage here high. Now imagine the 6 volt need to share, but here get high voltage. The base leh, if here you get a higher voltage, let's say 5 volt, down here you only get 1 volt. My point is the total must be 6 lah. Okay, so here the voltage will become very high, meaning down here the voltage will become very low. When base is very low, it cannot turn on. To turn on transistor circuit, the base voltage must be high enough. It doesn't have to be higher than the one on top, but the base voltage must increase a bit, must be high enough. Doesn't have to be higher than the one on top, but must be high enough. Okay, can. Oh yeah, also one more thing, in case you all don't know, the voltage depends on the resistance, just in case. If you have a smaller ratio of resistance, you have a smaller ratio of voltage as well. Meaning to say, let's say, resistance on top here is 1 ohm. Resistance here is 5 ohm. You know what? Here we'll get a voltage of 1 volt and 5 volt. If the ratio is 1 to 5 resistance, voltage will also be 1 to 5. The ratio will be the same. So lower resistance, lower voltage. Higher resistance, higher voltage. But total must be 6, always. Okay, I don't want to put in all this. I don't want to confuse you. But we can answer already. Resistance for P, diagram 1 is low. Diagram 2 is higher. Diagram 1 is lower than diagram 2. 5.1 is lower than diagram 5.2. Or 5.2 is higher also can. Teacher, must we copy the resistant or resistor P and put here? You can also is fine. You don't want also is fine. Teacher, I don't want to use the less than symbol. Can I write is less than? Can, up to you. So you can write exactly like how I did in blue pen, no problem. In SPM, no problem. You want to copy this in front here, also can, no problem. You don't want to write the symbol, you want to write words, also can. In SPM, all accepted. In SPM, all accepted. Okay. However, in essay question, you must copy lah. Yeah, in essay question, you must copy this. In structure question, optional. You copy also can, don't copy also is fine. It doesn't matter to us because the question is just right on top. Yeah, essay question is not, the question is not right on top. The question and the answer is separate, so you must copy. Okay, later when we do essay, you'll see lah. Okay, then base current. Base current very obvious. Here 100, here 0. Yeah, in the first picture, base current is high. Second picture, base current is low. So a lot of people will say 5.1 higher than 5.2. But if you ask me, I prefer if you say 5.1 got base current, 5.2 don't have base current. That would be even better. Okay. If you ask me, the best answer for me would be the base current flows in diagram 5.1 and the base current does not flow in diagram 5.2. This is the best answer, if you ask me. Okay, but in this year's SPM 2025, they also accepted if you just said diagram 5.1 greater than diagram 5.2. So sometimes have to see that particular schema also, like how lenient are they in this, but one flow, one don't flow, or you can just say higher than. Collector current also the same. Can we use the symbol? Yes, you can, because they also use the symbol. If you don't want, you can write collector current. Collector current flows in diagram 5.1. Collector current does not flow in diagram 5.2. Or if you just said diagram 5.1 is greater than diagram 5.2, they also accept. Okay, why I say one flow, one don't flow is a better answer is because memang the other one is a zero value. If you just say like higher or lower, right, it might mean that maybe the other one also got value, right? But it's just lower. Yeah, but okay also lah, like 0 is memang lower. Okay, here is 60, here is 0. Both also higher than, or one flow, one don't flow. Okay, but C, based on your answer in 5B1, B2, B3, relate the resistance of P and the base current. If resistance of P is lower, base current flows. That, if you ask me, that is the best answer. Or if the resistance of P is higher, base current does not flow. Base current will be 0, does not flow. Okay, maybe I write for diagram 5.1, resistance lower for P, then base current flow. Or you can use this to help you to write it out. Resistance of P in diagram 1 is lower, then base current will flow. Okay, you can write something like this. If the resistance of resistor P is low, low can, lower also can, then base current flows. If it's lower, base current will flow. If you want to say, you can also say another answer. If it is higher, then base current does not flow. Up to you. 5.2 is higher, does not flow in 5.2. Okay, can. And then another possible answer is that you can also say if the resistance is lower, then the base current flow is higher. You can also use this. If resistance P is lower, base current will be higher. The lower the resistance, the higher the base current. Something like that. But if you ask me, that is not the best answer. That is not the best answer. Because transistor circuit is very special one. You must have enough base voltage, then only the whole thing will turn on. Or else it just cannot turn on. It doesn't mean that you are higher, then it will confirm turn on. It's not just higher. You must be high enough. Then only you can turn on. Yeah, so the best answer is like this actually. Okay, but they are quite lenient this particular year. I would answer like this. This is the best way. And what about the relationship between base current and collector current? If you ask me, the best one is if the base current flow, then the collector current flow. If the base current does not flow, then the collector current does not flow. Okay, or you want to say if the base current is high, then the collector current will be high. Something like that. Yeah. If IB flows, then IC flows. Okay, or you want to say IB base current flow will cause collector current to flow. Also can. Okay. Or you can say if the base current is high, then the collector current will be high. Also can. You can also say base current is directly proportional to collector current. Also can. Okay, we can even draw a graph. It would be directly proportional. I don't know if you all have seen this graph before or not. Yeah, but if I draw a graph for IB and IC, it would be directly proportional. So a lot of different answer. Yeah, if one high, the other one high, also can. The higher, the higher. Also can. Increase, increase. Also can. But if you ask me, I feel this is the best relationship. Okay, so don't be too worried. Usually in SPM, we are pretty lenient. Yeah, as long as your answer is logical and it makes sense, then it's fine. Okay, if you feel paranoid, you don't want to write IB, then don't just write base current. You follow. Okay, you follow base current, collector current, right? Base current, collector current, base current, collector current. Just write one answer will do. Okay, then based on the values of base current and collector current in diagram 5.1, calculate the current amplification factor. Amplification factor is given, it's right here. Okay, beta equals to IC over IB. Quite generous, they gave 2 marks. That is because even though it's very straightforward, you just put in only. However, the units, you have to know your milli very well and your micro very well. Yeah, if you sub in like, okay, collector current 60 milliampere and then base current 100 microampere cannot cancel. Milli and micro cannot cancel. So you have to change. Milli is times 10 to the power of -3. Yeah, micro is times 10 to the power of -6. Okay, milliampere, microampere. And then only the ampere can cancel. So that's the part, the unit. And I get 600. Be careful, don't go and itchy hand write ampere. You write ampere, then wrong already. There's no unit one. The unit already cancel. Okay, so the part that is tricky is make sure you know how to change the unit to the same value. Okay, can? Yeah, this is not the usual, very straightforward kind of comparison question, if you ask me. Yeah, this one you need to have a little bit of knowledge. Like, for example, the cold day and hot night. Yeah. Okay. Oh, and then there's a part E some more, sorry. State the change that needs to be made to the position of the resistor in diagram 5.2 so that the bulb lights up at night. For your bulb to light up at night, because they say now it lights up during daytime. It doesn't light up during nighttime. So what should you do? Just switch the position. Okay, if this current circuit, this circuit right now lights up at the daytime, you just have to terbalik. Then it will light up at night already. Or if they tell you, right now this one light up when it's cold, can you change it so that it light up during when it's hot, cold and hot for a thermistor circuit? Or you just terbalik these two resistors also. Okay, when you terbalik, then it will work already. Yeah. If you want a proof, they say how to make it light up during at night. When it's night time, you put your LDR here. The resistance during nighttime will increase, so the voltage here will increase. This is the base voltage. As long as your base voltage here is high enough, you can turn on your transistor already. Then the bulb is going to light up already. I just need to focus on the base. Base needs to be high enough. Okay. So you just have to swap, then can work already. Okay. You can say something like this. You can write swap or interchange. Yeah. You can terbalik lah, that two position. Interchange the position of P and Q. Okay, then okay already. Terbalik the P and Q. All right. Question 6. This is a heat question. I remember a lot of students were complaining about this steam fish question. Let's see why. Okay, so we got two electric steamers used to steam fish. The specific latent heat of vaporization is released during condensation process. When you condense, by the way, means you are trying to convert gas become liquid. You're trying to cool down. Gas become liquid, you have to cool down, gas become liquid, release the heat energy, then only can cool down. Okay, they give all this, later only we come and look at the pictures. State the meaning of specific latent heat of vaporization. Vaporization got two. It can be liquid to gas, or it can be gas to liquid. Liquid to gas is called boiling. Gas to liquid is called condensation. Okay, you can say something like this. It is the heat absorbed during boiling. Okay, or you can say when you convert liquid to gas, or heat released. There's two. During condensation. Or you can, if you don't want to say condensation, you say gas to liquid. For 1 kg of substance without the change in temperature. Okay, people always forget that last part. You must mention without the change in temperature, or you can say at a fixed temperature, at a constant temperature also can. Okay. Why? Because when you change phase, boiling or condensation, when you change phase, you think about your heating curve, let's say. When you change phase, all this temperature never change one. Right not? The graph is flat one. Change phase won't change temperature. Like when you boil water, water only remain at 100 degrees Celsius at the boiling point. Does not change temperature. That part is important. Okay, must have 1 kg because they have the word specific. Okay. Next part. Compare, based on the diagram, compare the amount of heat absorbed by the fish if the steaming time is the same. Okay. Compare amount of heat absorbed if the steaming time is the same. The amount of heat absorbed depends on the power. Yeah, it depends on the power. So without looking at the volume of water and all, the one that is higher power would supply more heat. So therefore, diagram 6.1 is higher. That's why I say, you see, this comparison question is not so direct. Yeah, it's not just asking you to compare the power. They ask you to compare the amount of heat. Okay. Therefore, diagram 6.1 is higher than 6.2. Or 6.2 lower than 6.1 also can. Don't worry, if you don't want the symbol, you just write is greater than is fine. Yeah. Okay. Then part 2, the specific latent heat of vaporization released if 500 gram of water is condensed, based on diagram 1 and diagram 2. The specific latent heat of vaporization is a constant value, by the way. Right? Why? Because specific latent heat of vaporization is how much heat you need for 1 kg of water. So it doesn't matter they write 500, 700, 1,000 gram. It doesn't matter what is the weight here. The moment they have specific latent heat, it doesn't matter. In both diagrams, it will be the same. The values are the same. Yeah, for water, the value is already fixed. How much heat I need to boil water to condense water is already fixed for 1 kg of water. Yeah, it's already fixed. Diagram 6.1 is equals to diagram 6.2. You can write is equals to, is the same as, also can. You can use equal symbol, also correct. Part 3, the time taken by the fish to cook. This one is the controversial one. So there's a lot of different answers. There's a lot of different answers that they accept. You can say 6.1 greater than 6.2, accepted. 6.2 greater than 6.1, accepted. 6.1 equals to 6.2, also accepted. Okay, all 3 answers accepted. But that will later affect your relationship answers also. Okay, so they will look at, it's a little error lah, right? It's a very tiny error. But I'll tell you what's the best answer. Later, this will affect your answer in part C. Okay, so they will look at based on this to see your answer for part C later. Okay, time taken for the fish to cook. The problem is because the mass of fish is different, 2 kg and 1.2. The power is different. The amount of water also different. Okay, the amount of water is also different. So people be thinking like, oh, how do we see? Now, I don't think you have to look at the volume of water. Okay, if you ask me, if it's for me lah, how I would answer is I won't look at the volume of water. I will just see, okay, I'll produce this much of heat, and then this is the mass of the fish. Let's say if the mass of the fish is 1 kg, how much power do I get? If let's say it's a 1 kg fish, I'm going to divide by 2 to get 1 kg. And the power would be 0.9 kilowatt. Okay. Now, if this fish was 1 kg, how to get 1 kg? You divide by 1.2, you will get 1 kg. Now 1.2 over 1.2, you get 1 kg. This one, when I divide by 1.2, I'll find out that, oh, it is 1 kilowatt. Which means if I convert the fish to the same mass, 1 kg, diagram 2, 6.2 is supplying more heat for per kg of fish. You get what I mean? For let's say I assume it's the same 1 kg of fish, so I compare the same 1 kg of fish. I found out that maybe diagram 6.2 is supplying more heat. So I'm assuming that diagram 6.2 should cook a bit faster. Also, because the volume of water is more, maybe it means that it can produce more steam. Maybe it can cook the fish faster. So if I were to answer this question, I would say 6.2 will cook faster. Because if I make 1 kg of fish only, 1 kg of fish is getting more heat. Every kg will get 1 kilowatt, for example. This one, every kg will only get 0.9 kilowatt of power. Yeah, and also got more water means got more steam. More steam by right, maybe should cook faster. Okay, so I would say 6.2. Yeah, but because there is too many variables, like the power is different, the mass is different, the volume of water is different. So a lot of students, they answer differently. They accept all 3 different answers. Okay, they did accept all 3 different answers. They accepted all. But if you ask me, I would say diagram 6.1 would take longer to cook compared to diagram 6.2. That is my answer. They accepted if you write equals, they accept it if you write smaller than. All are correct. Okay, so depending on how you want to answer it, they accept all of it for this particular question. Okay, so part C, they say, based on your answer in B1, B2, B3, relate the quantity of heat with the specific latent heat of vaporization. You can say the quantity of heat does not affect the specific latent heat of vaporization. Or you can say, when the quantity of heat increase, the specific latent heat of vaporization is unchanged. Also can. Okay, got a few ways to answer this. One way is you can say, because the specific latent heat is the same, it will not change one. For 1 kg of water, specific means it's 1 kg of water. Yeah, it's already fixed. The quantity of heat does not affect the specific latent heat of vaporization. Okay, or you can say, when the quantity of heat increases, the specific latent heat of vaporization is unchanged. Okay, and then another one is the quantity of heat and the steaming time. I'm gonna say this one you must do based on your answer lah. The quantity of heat is when it's higher, the higher the quantity of heat, then the time taken for the fish to cook will also be greater. Okay, so we are saying 6.1 is a bit slower. It will take a longer time for the fish to cook, even though the amount of heat absorbed is greater. But you have to follow your comparison, right? Just now I already decided that in 6.1 time taken is greater. But you follow your answer. You can also say amount of heat is greater. Did I make a mistake just now? Time taken by the fish to cook in 6.1 is greater than 6.2. Yeah, okay. 6.1 is greater than 6.2. 6.1 is slower, 6.2 is faster. That's right. Okay. So I will have to follow my answer. Okay. Or you can also say when the amount of heat absorbed is greater, the time taken for the fish to cook is unchanged. Or amount of heat absorbed is greater, time taken for fish to cook is shorter. Follow your own answer. Okay, follow your own answer. The greater the quantity of heat, the greater the steaming time. Or you can write increase also can. As the quantity of heat increases, the steaming time increases. This is depending on my answer. Okay, you can follow your answer. Maybe your answer is the greater the amount of heat, then the shorter the steaming time. Also can, right? But if you wrote equal, you feel like they take the same amount of time, then maybe you can say the quantity of heat does not affect the steaming time. Or when the quantity of heat increase, the steaming time is unchanged. Got 3 possible answers depending on what you wrote just now in part B3. Okay, so this question has a little error because even if you see this sentence, it doesn't really make sense. But because question already say based on your answer here, so you just follow only. Yeah, you just follow only. Okay, so there's a little problem with this question. A lot of students got stuck here. but you just follow only. Okay. Part D, calculate the amount of heat absorbed by the fish when 500 gram of steam condenses on the fish. Okay. The amount of heat is Q. 500 gram is the mass. This is the latent heat. There is a very easy formula lah, called Q equals to ml. Yeah, Q equals to ml. Got latent heat and mass. Just use only. This is a pretty straightforward one. But the mass you have to change to kg. Oh. Latent heat is 2.26 times 10 to the power of... then 2.26 times 10 to... Oh, there's a typo here. Sorry, guys. It's supposed to be 10 to the power of 6. There's a typo in here. In SPM, there was no typo. This one is just that they forget to type it when they retyped. But by the way, if SPM only put 2.26 times 10 like that, don't have the power 6, you just follow only, right? If there is an error, you just follow only, just do only, just do whatever you can. Don't leave it blank. Yeah. If it's a error for that question, they will still mark it for you, even if really don't have, even if really got typo. Okay, Ken? Just don't forget to change to kg, you divide by 1,000. I get 1.13 times 10 to the power of 6 joules. Okay. SI unit for heat would be joules. You want to write 113,000 joules. Also can. Yeah. Question number 7. Diagram 7.1 shows a simple homopolar motor that consists of a conductor, a dry cell, and a neodymium magnet. It's just a type of permanent magnet. When the part of the conductor labeled Q touches the positive terminal of the dry cell, the conductor will rotate. Okay, so this is the conductor. The conductor will rotate. Conductor is just a piece of wire, by the way. Part A, state the physics rule used to determine the direction of rotation of the conductor. You're trying to find force. You have some magnet. You have a B, you have magnet, and then you have current flowing through the wire. There's I. When there's B and there's I, you know you are trying to find F. Okay, guys, if you are trying to find F, which is on the left side, F is on the left side, you use your Fleming's left-hand rule. If the question is asking you to find out the induced current, okay, if you're trying to find the current is on the right side, right now. Then you use your Fleming's right-hand rule. So depending on what are you looking for, now we are trying to find the force that makes it spin. The force is the reason why it will spin. Okay, and this is Fleming's left-hand rule. There's one problem usually that some students face, the spelling. You might lose mark if you spell Fleming's wrong. Yeah, Fleming only got one M. A lot of people will spell double M, then wrong already. Okay, our name must be correct. Part B, based on the diagram, state the direction of force on wire R. So you try and see to use your Fleming's left-hand rule. Your 3 fingers, the force is your thumb, the B finger is your magnet finger, and then the I is your current. Okay, please do one at a time and make sure you're using your left hand. My watch hand is my left hand. Okay, and guys, the video might be flipped. So if my fingers look like it's the ballet or what, it looks like I'm using my right hand, don't follow my video, you try yourself. Okay, number 1, make sure that your B finger, your index finger is pointing up. Because you're doing north to south, pointing up. Make sure your current finger is pointing to the right side because the current is flowing in like this. So number 1, you point up first. Left hand, my watch hand is my left hand, up. And then middle finger, you point to the right. This is my right side lah. You follow your own right side. I know the video might be terbalik or how. And then my thumb will be pointing to myself. My thumb will be pointing to myself. So I point index finger up. Current, I point to the right side. Middle fingers to the right side. One by one, up. And then middle finger to the right. and then thumb will naturally be pointing at myself. Pointing at myself, meaning it is coming out from the paper, you know. Your exam papers like that is coming out from the exam paper, your thumb, the force. Okay? Coming out from the screen. If it is coming out, meaning that this coil is going to spin like that. It's going to spin from the front. It's coming out. Come out and spin. A bit hard to draw lah, because this one need to draw like 3D. But you get what I mean. The force that you get is like it's spinning outwards. So we say the direction of force on wire R is out from the paper. Wait, this is how you would explain, huh? Come out from the paper or go into the paper. This is in and out if they ask you to talk about like 3D. Okay, part C, based on diagram 7.1, current flows through the conductor when the conductor is in contact with the dry cell. State the change of energy that occurs in the conductor. Energy change. You have electrical energy, you have current. You got battery, you got current. And then this electrical energy will help to convert to a force, a kinetic energy. Can? A force meaning a kinetic energy to start to spin this thing. So this is the whole concept of a motor. Okay, a homopolar motor. It's just a type of motor, by the way. Any motor is to use force to help to spin something. For example, to spin a fan. Yeah, your fan also will spin using a motor. But we use electrical energy convert to kinetic. Okay, you can just arrow, teacher, I want to write to, can or not? Can, it doesn't matter. Okay, electrical to kinetic. But the neodymium magnet has high magnetic field strength. Explain why a high magnetic field strength is required in the homopolar motor. I want something with a high B so that I get a high F. You can just say that, so that I produce high force, for example. Or so that I produce a strong catapult field, also can. Okay, so that I produce a strong resultant, catapult field is the same as resultant magnetic field, also can. Yeah, the answer they want is actually pretty simple. Okay, then part E, the diagram shows characteristics of conductors that can be used to build a homopolar motor. Based on diagram 7.2, state the suitable characteristics of a conductor to ensure it rotates quickly. Okay, I want it to rotate faster. Conductor, definitely we want copper. You have to know two important material in your syllabus for wire. There's nichrome and there's copper. Nichrome is the one with the highest resistivity, therefore highest resistance. Copper is very low resistivity, therefore very low resistance. Okay, and then somewhere in the middle you have constantan, which we rarely use for any real life application, but these two must know. Okay, I use this a lot for heating element. I use this when I want high current. Okay, when I want high current, low resistance for any like wire conductor and stuff. Okay, so definitely copper. And the thickness of conductor, I want it to be high also. A greater thickness means low resistance. A thick wire, very easy for current to flow. Therefore, very high current. The issue is this SWG, this standard wire gauge is terbalik. A higher thickness is a lower SWG. Greater thickness is the same as lower SWG. So that is the confusing part. This one is the thickest actually. Okay, this one is actually the thickest. So material of conductor, I will choose copper. Follow the table, copper. Reason, because copper has low resistivity. Okay, correct. You can say copper has low resistance, also correct. Copper can produce a high force, also correct. Because the force is, because the current flow is very high, or high current also can. Current flow is very high, therefore the magnetic field strength also very high. High magnetic field strength. Okay, thickness of conductor. Normally we don't put the number. Yeah, normally we don't put the number. So you can just say I want a greater thickness. Or higher thickness. But if you want to write the standard wire gauge, the SWG, then you can write I want a lower SWG. We don't have to say the number. Okay, a lower SWG is, it means that it is a greater thickness. Why, teacher, why do they terbalik the number and all? This one is just how they fix it. Yeah, the standard wire gauge is terbalik one. The thicker the wire, the lower the value. Yeah. And the reason is all the same, except for don't say low resistivity. Everything all correct, the same, except for low resistivity is wrong. Okay, but everything else is the same reason. It will still give you lower resistance, high force, high current, high magnetic field strength. Why low resistivity cannot write here? Because resistivity is only for type of material. Different type of material got different resistivity. Resistivity is this symbol. Resistance is this symbol. Yeah. But thickness doesn't affect the resistivity. It only affects the resistance. Yeah. And also, by the way, thickness is talking about this area. If your area is big, thicker wire, big area, then resistance will be small. Okay. Same thing, if your resistivity is low, like for copper, then your resistance also will be low. Yeah. Teacher, can I write both also low resistance, low resistance? Can. You'll be marked correct. No problem. Can, no problem. Yeah. Okay, part F. The homopolar motor in diagram 7.1 requires a suitable dry cell, to ensure the conductor rotates faster. You got two different dry cell. Based on the diagram, which dry cell will make the conductor rotate faster? Which one do you think will make, you can say this one, no? Because higher EMF, higher voltage, higher current should be able to rotate faster. Which dry cell? You can say the one that is 3.7 volts. The 3.7 volt dry cell. Teacher, I thought don't write the number, but they asked us to choose based on the picture, ma. Right? So this one okay lah, if you write 3.7. If you don't want, they also accept if you write, choose the one with high EMF or choose the one with high voltage. Okay, the high voltage EMF, the high voltage or high EMF dry cell. Okay. Question number 8. Diagram 8 shows a rocket launched from the surface of the Earth. This is gravitational. The rocket needs to overcome gravitational field strength of Earth to escape into space. State the meaning of gravitational field strength. Okay, this is the G actually. Yeah, you can find the, let me see. Oh, they didn't give the formula for weight. But by the way, force is the same as weight, right? Force is gravitational field. Sorry, weight is gravitational force. Weight and force, same. And then mass is mass. The A value you can write as G value. This is how we get W equals to mg. Okay. I was looking for this because to get the G value, right, you can say it is weight divided by mass. You get marked already. If you write weight divided by mass, weight per unit mass, correct, they accept. Okay, the textbook version, they go and change the weight to gravitational force, because weight and gravitational force is the same. Per unit means divide. Okay, something like that. You can also say it is the force per unit mass caused by gravitational. Oh, I forgot a word, force. You can say it is force. Sorry, I write wrong. Okay. Force per unit mass due to gravitational, or due to gravitational pull, or due to gravity also can. Force per unit mass due to gravitational pull, or straight away gravitational force per unit mass, or straight away just weight per mass, all accepted. Okay, but B, calculate the escape velocity of Earth. Oh, so just to let you all know, for in SPM 2022, they gave the mass of Earth and the radius of Earth in the formula sheet. Okay, they told the students that radius of Earth is 6.37 times 10 to the power of 6 meter in the formula sheet. They also gave the mass of Earth, which is 5.97 times 10 to the power of 24 kg. Yeah, my current formula sheet don't have the mass of Earth and also the radius of Earth, but escape velocity you can get from here. Right? By the way, don't mix up number 8 and number 10, no? Number 8 is called linear speed. Number 10 is called escape velocity. One has a 2, one doesn't have a 2. Okay, we are using number 10, square root 2 gm over r. And by the way, because escape velocity, you are counting from the surface of the Earth usually. So therefore, you can straight away use the distance as the radius of Earth. Yeah, so some people, they will write like that also. 2 gm, oops, sorry. 2 gm over big letter R. Same thing. Both are correct. Okay, the G value is given 6.67 times 10 to the power of negative 11. That's your gravitational constant. Mass of Earth in SPM they gave. Okay, radius of Earth they also gave in the formula sheet. Oops, hold on. Okay, I get 1181.379 meter per second. Okay, best to do 3 decimal, please. You want to write more also can. Okay, that's 2 marks. Part B, rocket in diagram 8 moves with a lower velocity than the escape velocity. Suggest modifications so that the rocket can reach greater speed. Give reason for your answer. Power of engine is 3 marks. Of course, you want it to be high power. High power, higher power also can. A high power always means that you get more thrust, more force, more energy, more acceleration. Oh, okay. I'll produce a high or higher force. Thrust also can. Energy also can. Acceleration also can. Anyone. Yeah, or you want to write to produce. By the way, a thrust means a forward force, a forward push. Yeah, mass of rocket. Of course, if it's a lighter rocket, it'll be easier for you to move up. Or if it's a lighter rocket, then the acceleration will be higher. Okay, I want a low mass of rocket or lower mass of rocket also can. You can produce a higher acceleration. Okay. Or by the way, if you say like Teacher, what if I wrote like, I want a light rocket? Can or not? Can, also can. I can produce a higher acceleration. I can also get a low inertia so that it's easier for you to move if you're trying to escape to outer space, right? Inertia is talking about the rocket, because the rocket is quite heavy. But if you choose something that is lighter, it's easier for you to move the rocket. Low inertia means easier for you to move the rocket, easier for you to throw it up to space. And the acceleration one is talking about F equals ma lah. Like usual, if I got a smaller mass of rocket, I will have greater acceleration. Okay, you can also say I will need lower amount of fuel to accelerate the rocket. I don't need so much fuel. I need lower amount of fuel. I can save some fuel. Yeah. You can also say that if the acceleration is high, then the resultant force will be high. Easier for you to push the rocket up to a greater speed. Rate of fuel combustion is high. When you burn more fuel, you produce more force, more thrust. Produce high force, high thrust, high acceleration, high energy, large momentum also. Because how you launch your rocket is depending on the amount of exhaust gas that shoot out. Yeah, if you have a large amount of exhaust gas that shoot out, a large momentum, then the rocket is also going to gain a very big momentum. This is explosion in your principle of conservation of momentum. You shoot a lot of exhaust gas, rocket also will gain a lot of momentum forward. So the rocket can go up faster with more forward force, forward thrust, acceleration. Okay, I think this is quite easy to score full marks at this part, actually. Okay, because these are things that you all write, you all see a lot and write a lot. Yeah, if all of it you write high acceleration, high acceleration, high acceleration, also mark correct. Because it is the best answer. It's one of the best answers. Okay, question number 9, section B finally. Yeah? Okay, the diagram shows a train moving with a velocity of 20 meter per second. Then they give you the velocity time graph that shows the velocity change in velocity of the train in 10 seconds. State the meaning of velocity of 20 meter per second. You just try to explain velocity is displacement divided by time. 20 meter per second is the displacement is 20 meter in 1 second, right? The displacement traveled is 20 meter in 1 second. Or you can say displacement is 20 meter per second or per unit time. Also can. Okay, part B, based on diagram 9.2, calculate the acceleration of the train from 2 to 6 seconds. Now, I always tell my students, this is for a linear motion graph, that you must always know your displacement to velocity to acceleration, how to convert. And you must always know what graph are you given. What do you have? You have a velocity graph. Okay, you have a velocity graph. Now, guys, if you are trying to go forward, let's say I got S graph, I want to find V, or I got V graph, I want to find A. If you're going forward in this order, S, V, A, displacement, velocity, acceleration, then please find the gradient. But if you're trying to move backwards, let's say I got a acceleration graph, I want to find velocity, or I got velocity graph, I want to find displacement. Then you find the area under the graph. Okay, right now, you're trying to find acceleration. I got velocity graph, I want to find acceleration. So guys, this is what we are going to do. We are going to find gradient. I got velocity, I want to find acceleration. Find the gradient from 2 to 6 seconds. Done already. Okay, so in part B1, the acceleration is actually just the gradient. And how to do gradient? You can write down some coordinates. This is 220. This is 640. Okay, you don't need to write this lah. You can straight away do y2 minus y1 over x2 minus x1. Teacher, can I do 40 minus 20 over 6 minus 2? Can, it doesn't matter. The answer will be exactly the same. 5 meter per second squared. How do I know the unit is 5 meter per second squared? Well, because velocity, the y-axis, is meter per second. The x-axis is time. So to get seconds. So together is meter per second squared. There you go. Okay, there you go. And then part 2, find the average velocity of the train from 0 to 10 seconds. Now, average velocity is a little bit tricky because it is equals to the total displacement divided by the total time. The problem is we do not know what is our total displacement, and you need to find out your total displacement first. To find total displacement, you need to go from velocity graph to displacement. You need to find the whole area under the graph first. Okay, and got many ways you can do it. You can treat this as a rectangle, this as a trapezium, and then this as another rectangle. Add 1, 2, 3 up. Okay, or some people, you are a bit more creative. You can say, teacher, what if I look at this one is one big rectangle, and then on top is one trapezium? Can also. It's a bit faster. Yeah, you just need to add 2. So up to you. Yeah, how you want to do it. All accepted. Huh? You want to do like that, plus like this. Can, is correct. You don't want, you want to do slowly. This one plus this one plus this one. Can also. Okay, but we're going to do the total displacement first. If you want to just write S, can also. The first one is just 2 times 20, right? 2 times 20. The second area is half trapezium, half times 20 plus 40 divide, sorry, not divide. I should just write it out. Half times 20 plus 40, the parallel sides, and here's 4. Okay, one last one is just a rectangle. This is 4 multiply 40. Okay, just add everything up. That is the total area underneath. That is the total displacement. Okay, can make sure you know how to do trapezium. This is the parallel sides. Plus together, multiply with the height. I get 320 meters. Okay, then the average velocity is equals to 320 meter total displacement divided by total time. The total time taken is only 10 seconds. (32 meter per second. Like that only. That is the answer. Okay, can. So you get 5 marks for doing all this. Okay, can. Then we move on to part C. When the train in diagram 9.1 is moving with a velocity of 40, it takes a long time to stop when the brakes are applied on it. Explain the situation using suitable physics concept. When something is moving quite fast, not something, the train is moving quite fast, it's very difficult to stop it. This concept is related to, definitely, you can talk about inertia. You can talk about momentum also. Okay, so one good point is you, first of all, establish and say the train has a big mass, therefore big inertia. Also, because the velocity is high and the train is heavy, momentum is equals to mass times velocity. If your mass is high, your velocity is high, you have a big momentum, which is why it is difficult to stop also. So got a lot of things to say. Huh? Talk about momentum, talk about inertia, both. Okay, so I say number one, train has big mass. Okay, train has big inertia, high inertia. 2 marks already. Train has a big momentum, or if you want to add a big forward momentum, optional. Okay, how do I know it has a big forward momentum? Well, because momentum is equals to mass times velocity. In words, we write it as momentum is the product of mass and velocity. Okay, momentum is the product of mass and velocity. So when your mass is high and you are moving quite fast, that is the reason why you have a big momentum, just now we say. Okay, teacher, what if I never write in English? I write like momentum equals to mass multiply velocity. Is it okay? It depends. Yeah, if the examiner is fine with it, then it's usually okay. Usually in SPM, it is okay. Okay, what else? I can say when the train is moving like this so fast, the train has a big force also. Large forward force or large resultant force, if you like. Okay, that is the reason why it takes a long time to stop even when the brakes are applied to it. Maybe you can talk a little bit about how we need a lot of friction. The brakes are trying to slow down the wheels, let's say. We need a lot of friction to try to stop it because it has a very big forward force. Okay, large force in the opposite direction is needed to stop the train. This force, if you want to say it is frictional force, also can. Okay, a large frictional force is needed to stop the train, or a large force in the opposite direction is needed to stop the train. Can. Right, so got a lot of things to say. Quite easy to get 4 marks. You mentioned big mass, big inertia, big momentum already, 3 marks. Then you mentioned one more like big force, 4 marks. 4 marks already like that. Okay, and then you can, that's why you sometimes throw in whatever you know, like momentum is mass and velocity times together, or like mass and inertia always one big, the other one also always big. Yeah. Okay. Part D. The train in diagram 9.1 needs to be modified to an electric train so that it can move faster and further. A transformer in the train is used to vary. Okay, there's also a transformer to vary the potential difference and produce different velocities. So sometimes I step up, sometimes I step down so that the velocity is different. Okay. You are required to study the characteristics of electric train in table 1. Explain the suitability for each characteristics of the electric train. Determine the most suitable one that can move faster and further. The shape of the head of the train must be aerodynamic. Okay, the head, the front part of the train, normally they look like this. Those bullet train normally look like that. Where, because it's moving so fast, right? When the air moves, it will glide very easily. It will reduce air resistance. Aerofoil, we only use it for producing lift force. Okay, so if anyone confused between aerodynamic and aerofoil, this is the difference. Aerofoil is for aeroplane wings to produce lift so that you can lift the aeroplane higher. Aerodynamic is to reduce air resistance, reduce air drag. Air drag, air resistance also can. Okay, density of material of the body of the train. This is free mark lah. Confirm low density, lighter, yeah. Engine power of the train, confirm I want high. All this free mark. And then type of current of power supply, because there is a transformer, so therefore I must use an alternating current. A transformer cannot work with a direct current. This one is your Form 5 chapter 4. So they try to mix a little bit with Form 5 topic. Yeah, alternating current. Because alternating current can produce a changing magnetic field. Okay, so therefore L is chosen. Yeah, L is chosen. I've given the answer already, and now L is chosen. This is the reason that you can write. Yeah, I choose aerodynamic, can reduce air resistance. This is the highlight. You can say reduce drag or friction also can. When you reduce the air resistance, then you have more forward force, higher acceleration. Low density of the material of the body of the train. Low density, just say light, already get marked. Low inertia, can accelerate faster, higher. High engine power, more forward force, forward thrust, energy, acceleration, big momentum, big change of momentum, big impulse. Yeah, you can speed up very fast. Your momentum can change very fast. Impulse can be very high. I choose alternating current so that voltage can increase or decrease, can step up, step down. Engine or the transformer can turn on, can function, can operate, can be activated. If you ask me, I like this the most, to produce changing magnetic field. If you are able to write this sentence, I know you have the correct idea already. You have the correct concept. Because transformer requires AC, alternating current, then only it can work. Because we need that changing of magnetic field to have cutting of magnetic flux, to induce EMF, to induce the voltage, to induce the current. That is how a transformer works. Then only the output voltage can be produced. Okay, so if you ask me, this is not a difficult essay lah. Yeah, but overall it is a pretty interesting question. Especially I feel if you're not very good at the graphs, then you might get a bit stuck here. Yeah, but other than that, this question should be okay lah. Yeah. Question number 10. Table 2 shows specification of copper wire that is connected to a circuit. So they gave radius, length, and resistivity. Based on the data in table 2, what is meant by resistivity? Okay, you know this is done on purpose, if you ask me. Why? Because resistivity is a pretty uncommon definition that they last time never really asked. But this is the third consecutive year that they asked the meaning of resistivity in SPM in paper 2. Yeah, it is quite a long one. Right at the side here. It is the measure of a conductor's ability, or the conductor's ability also can, to oppose the flow of current. This is your textbook answer. The measure of the conductor's ability to oppose the current. It depends on the type of material. So like copper would have a different value. Nichrome will have a different value. Yeah. Okay. But to calculate the resistance of the copper wire, use pi equals to 3.142 in your calculation. Okay, this has probably something to do with the area of a circle. The formula is that R equals to rho L over A, that one. Okay, let me show you. This one. Okay, you sum in the resistivity, the length, as well as the area will do. Oh, the only issue is, I do here. The only issue is the units and also the area they didn't give. Resistivity, you can use straight away in ohm meter. The length, you have to change to meter. So 7 cm would mean it is 0.07 meter. You have to divide by 100. Huh? And this one is radius, you know. Radius is 0.38 millimeter, which is 0.38 times 10 to the power of negative 3 meter. Or you want to write as 0.00038 meter. Also can. Also can. Right? So I feel you want to sub in straight away. All right, that is fine. That'll be 1.68 times 10 to the power of negative 8. The length 0.07 meter. Everything must be SI unit. And then the area. Now the wire, if they give you radius, it means that it must be circular. And the area would be pi r squared. Okay, so this one if you don't know, then you cannot do. Okay, pi r squared you can do straight away here. You want to do separately also can. Then you do separately and then you sub in. Or pi r, I think I just follow 0.38 times 10 to the power of negative 3. Don't forget to square. It doesn't matter though, you can write either one. Then we type everything in the calculator and you can get full mark already. So they purposely want to make this one not so straightforward lah. But 2 years ago, they also asked a similar question like this. But that one, they gave the area lah straight away. Okay, so R is equals to 2.592. If you round off to 3 decimal, it's 2.592 times 10 to the power of negative 3 ohm. You want to do 0.002592 ohm. Also can, it is the same. Okay, either one. Huh? Then part 3, calculate the power dissipated from the copper wire when the potential difference across the wire is 10 volts. So they give you the voltage. They ask you to find power. And you have the resistance. If you look at the formula sheet, power only got these two. This one is voltage and current. But right now you have voltage and resistance. So how? You can take this formula. You either go and find out what is your current. Okay, you either go and find out what is your current, or you go and substitute the current away because you don't have current. And according to V equals to IR, current is V over R. So what you can do is you take this formula and you replace the I as V over R. And then you get a new formula like this. And then you can sub in straight away. The voltage is 10. The resistance is 2.592 times 10 to the power of negative 3 ohm. Okay. Yes, this formula is not given directly, but in your textbook, in your syllabus, actually, we did go through with you all this, where P equals to VI is the standard one. If you don't have the current, you can always just replace the current as V over R. Yeah. And you can do like this. Power, I get 38,580.247. That is in watts. Okay, 0.2247. You might get a slightly different answer. It doesn't matter one. It depends on what value you sub in. So your answer don't have to follow mine. Follow your value. As long as it's 38,580 something. The decimal behind different, never mind. It is okay. Teacher, if I don't want to do all this, can I find the current first? Can. A different method would be you go and find what is the current first. You go and do 10 volts divided by your 2.592 times 10 to the power of negative 3 first. After you find out what is your current, then you substitute your current inside here. Okay, and you do P equals to VI and find out what is the power. Your answer will be very similar. Okay, it will look different just because you round off only. Okay, then part B, a lot of people are very scared about this formula. They say the electrical energy through a copper wire can be calculated using this formula. Yeah, where E is electrical energy, V is potential difference, I is current, T is time. Derive this formula based on the definition of potential difference and the definition of electric current. The definition of potential difference and electric current is this one and this one, where they say current is rate of flow of charge divided by T. This is current. The definition of current is rate of flow of charge, Q divided by T. The definition of voltage is energy or work done to move 1 coulomb of charge from one point to another point. So these are the definition. They just make it sound like very fancy, but it is given in the formula sheet. Just take from here only. Okay, so you take from there. Current is Q over T. Voltage is energy for 1 coulomb of charge. And then you try to get E equals to VIT. How to get the E? Then you go and find this guy first. E equals to V times Q, right now. And then you go and multiply the Q so that Q is equals to I times T. Okay, maybe I write like that. Q equals to I times T. If you want, you can call out this one equation 1, this one equation 2, right? And then you sub 1 inside of 2. You don't need to write all this actually, as long as I see how you go from the formula in the formula sheet and slowly get the final answer, then can already. Okay, but basically you sub equation 1 into 2. This is how we get it, like that. Done. 2 marks. Formula given, just sub in only, just put in only until you get the answer. Okay, and then in part 2, they say, given that power is energy over time and V is equals to IR, derive this formula, P equals to V squared over R. Oh, okay. So just now also I already got P equals to V squared over R, right? Like that. It's just that I did it using P equals to VI. Now they ask you, can you go and do P equals to E over T? So just that part a bit different. But it is very similar actually. In B2, we start like this. Okay, and then later I need to use V equals to IR. And then I want to get V squared over R. The problem is right now I need to find a way to remove the E. What is E? E is this, VIT. When you put in E equals to VIT, you straight away get 1 mark already. The T can cancel. This is how you get P equals to VI. And then guys, the rest of the steps look exactly the same as what I did just now. Yeah, from P equals to VI, you slowly get into here. Guys, you see or not? This formula has V and R. This formula has V and I. Okay, power actually got 3 formula. I don't know whether you all know this or not. You got P equals to VI, got voltage, got current. This one is got voltage, got resistance. And then there's another version where you have current and resistance. Right? So according to your V equals to IR, you are just playing with this formula V equals to IR. Yeah, sometimes I want V and I, sometimes I want V and R, sometimes I want I and R. Depends what info you have. Okay, so what you do is you try to remove the current. Okay, try to remove the current, but you show the working a bit now. V equals to IR. The current is equals to V divided by R. Okay, you make I the subject. Current is V divided by R. You want to call this equation 1, can? You can call this equation 2 if you like. You can say I sub in 1 into 2. Okay, sorry. The I is equals to V over R, and therefore power is V squared over R. Done. Okay, just like that. 5 marks. You get 1 mark for substituting VIT. Then you get this. Then you get another mark when you sub in the current is V over R. Then you get another mark when you get the final answer. Okay. Sorry, not 5 marks. 2 marks, 2 marks. So total 4 marks. Okay. Okay, part C. Diagram 10 shows a brick toaster. The toaster has an electromagnet which is used to produce a force that holds the metal handle containing the bread to remain in its position during the bread toasting process. A spring in the toaster pulls the metal handle upwards when the bread toasting process is over. So it's like those typical toaster where when you press down, it will toast the bread, but when the bread finish toasting, it will bounce the bread up. You need the spring to bounce it up. We use a electromagnet to control this metal handle, to hold on to this handle so that it press the spring down. The toaster needs to toast 250 pieces of bread within 4 hours in a food festival. Okay, we got different toasters, and then they say explain the suitability. We want the most effective toaster. Okay, I want resistivity to be high for sure. Yeah, because high resistivity produce high resistance. When the heating element has very high resistance, a lot of electrical energy can convert to heat. When the resistance is very high, you will force electricity, because it's so hard for current to flow, you will force the electrical energy to convert into something else. And in this case, you will force it to become a heat energy. Yeah. So heating element is just a piece of wire, that becomes very hot when current flows through. Okay. Spring constant, I want it to be large, because a large spring constant means the spring is harder, stiffer. It has higher spring constant. It is a harder spring, stiffer spring. A very stiff spring will produce a lot of force, can bounce very high. Okay, and thickness of wire. So if you have a thick wire, then also spring constant will be high. It will be a harder spring, stiffer spring. Very hard to pull, yes. But when you compress and you let go, it will bounce off bounce off with a big force. Yeah. The elasticity is very high. It go back to original shape and size very fast. Bounce up faster. And strength of magnetic field, of course, is stronger. If you have a strong magnetic field, then you will have a strong force also. Right? Strong electromagnet, then strong force, push down the spring with a larger force and all. Okay, so the clear winner is Y. Yeah, so this is a heating element question, but they try to make it special a little bit. They talk a bit about the spring, Yeah, okay. So we say, just follow the table. We want high resistivity, large spring constant. Okay, high resistivity, high resistance, produce more heat. I feel this is the best. Large spring constant, produce a lot of force, high velocity, short time for the brake to move upwards, high elastic or potential or potential energy, can withstand a lot of force. I think you can also say, oh, I wanted to say high spring constant. Okay, sorry, the high spring constant is the characteristic. Yeah, produce a lot of force, can bounce up very high. Okay, short time for the brake to move up. A large thickness, best answer, high K value. Teacher, can I say the same thing? Here you write high spring constant. Here you also write large spring constant. Can or not? Yeah, it's fine. Okay, if you're scared, then you can say it will produce a stiffer spring, a harder spring. You can also say here, it will produce a stiffer or harder spring. Also accepted. Okay. For the thickness one also the same. Yeah. Am I right here? Stiffer or harder spring? High stiffness, very elastic spring, can withstand a lot of force, can produce a lot of elastic potential energy to bounce the spring upwards. When it bounces up, it will move very fast. Yeah, a lot of different answers. Strong magnetic field strength can produce a lot of force. Yeah, therefore Y is chosen. Okay, I think quite easy to get full marks also, this essay. Just that got some parts lah, some students find a bit scared. Like when they see the formula, all this, they will feel scared. Yeah, they'll be scared of this kind of question, some people. Yeah, but I just want you all to know, if you try, right, you will notice that it's actually very easy to derive these formulas because they guide you on. In physics, they will guide you on, not like admits. In physics, they will guide you what to use, how to get it and all. Okay, you just start in only. Okay, last one, section C. Diagram 11.1 shows a boy releasing a sky lantern. The flame caused the sky lantern to rise in the air. State the name of the physics principle that caused the sky lantern to rise in the air. Okay, this one, the problem usually is spelling. Archimedes Principle. It's spelled as Archimedes Principle. Spelling, if it's wrong, you lose your mark. Yeah, spelling must be correct. Archimedes Principle. Then explain how the sky lantern rise in the air. You just explain like hot air balloon like this. Okay, the air inside must be hot. The temperature inside must be high. The density is low when it's very hot inside. Yeah, something that is light, that is low dense can easily fly up one. Just like those helium balloon. Helium balloon can fly up. Why can fly up? Oh, because I got some buoyant force. This buoyant force comes from V rho G. Yeah, when you displace some volume of air, you are going to get buoyant force. Okay, and how does it rise up? Oh, because the FB is bigger than the weight of the lantern. That's why it can rise up. Okay, so there's so many points to say. Number one, you can say, maybe I write here, the temperature of air in the sky lantern is high. Or you can just say, the air in the sky lantern is hot. Air in the sky lantern has low density, or has lower density if you want. Buoyant force is produced on the sky lantern. You can go and explain why is there a buoyant force, but it is optional. You can just stop here. But if you want to say buoyant force is produced on the sky lantern as it displays volume of air. Okay, when you displace air, you are going to get buoyant force. But if you never write this, already got marked. When you mention buoyant force, already got marked. And then you know what? Sometimes, whatever put down, including the formula, buoyant force has a formula of rho Vg. Okay, rho Vg. You get 1 mark for that. And then sky lantern can rise up because I want to say the buoyant force is bigger than the weight of the lantern. Okay. Upward resultant force is produced Why? Because buoyant force is greater than weight of sky lantern. Okay. All these points can say. Okay, or you want to switch the last 2 points, you want to say buoyant force greater first, that's why you got an upward resultant force produced. Or you want to say got upward resultant force because buoyant force is greater. Also can. It doesn't matter the order. Yeah. Okay, that explains why sky lantern will rise up. Can. And then in part C, they say diagram 11.2 shows two identical sky lanterns, P and Q. Only the flames are different. Okay, the flames are different. The two sky lanterns were released at the same time are at different heights. So the flame, one small, one big. Okay, so I believe one is hotter inside, one is not so hot inside, which is why one is higher and one is lower. They ask you to compare the temperature of air in the sky lantern, density of air in the sky lantern, and the buoyant force experienced by the sky lanterns. Okay. Temperature of air in the sky lantern, I want to say Q is hotter. Okay, Q has higher temperature than P. Density of air in the sky lantern, Q is lower density. Lower density, this is the symbol for density. So Q is lower density than P. Then the buoyant force experienced by the sky lantern, Q has more buoyant force. Okay, Q has more buoyant force. That's why it can fly higher. And when you write your answer, you have to copy the question. For essay, this is what I mean. You have to copy down the temperature of air in the sky lantern. This one I already write. You copy down and then you say Q is higher than sky lantern P. Density of air in sky lantern Q is lower than P. Or you want to say P is higher, the balik is fine. Buoyant force experienced by sky lantern Q is higher than P. Can. Okay. State the relationship between temperature of air and density. When it is hot, high temperature, density will be low. Yeah, hot air is always low dense. The greater, the smaller. Or the higher the temperature, the lower the density. Can. And then another one, density of air in sky lantern and buoyant force. If the density of air in the sky lantern is lower, yeah, inside here is lower density, then buoyant force will be higher. Yeah. The lower the density of air in the sky lantern, the higher the buoyant force. You can just use this to answer also. Lower density for Q, higher buoyant force for Q. Okay, you can use all this answer. Teacher, if I don't want to write greater than, smaller than, this symbol, you just write in words. Is higher than, is lower than, is higher than. Can I write P first instead of Q first? Can. P is smaller than Q, or Q is bigger than P. Same thing. It doesn't matter one. Don't get too paranoid here, but must copy the question. What are you comparing? Okay, structure question don't need to copy, is fine, but essay question must copy. Okay, part B, diagram 11.3 shows the hot air balloon used to carry tourists to observe surrounding scenery from the air in a recreational activity. As an engineer, we are required to modify hot air balloons so that it can accommodate more tourists safely, float in air for a longer time, and rise to a higher position. Use suitable physics concept, explain the burner, material of balloon and basket, and any additional equipment. Okay. So a few things that you can say. Burner, you want more burner. Yeah, more burner. So that you can burn the air inside the balloon faster. Material of balloon, You can choose something that is light, something that is strong, something where air cannot pass through, right? Or else the air keep on escaping. Something where the uh where it is fireproof, maybe waterproof. And there's one good material for this balloon, where you can use nylon. Yeah, you can use nylon. The basket, you can use, again, a strong material, a light material. There's one very good material for the basket. You can use rotan, or in English is rattan. Yeah, so got a lot of things you can say actually. I want many number of balloons, or more burners, sorry, so that I get very high temperature in the balloon, or low density, or air can heat up very fast. I can increase buoyant force. Okay, you can even talk about type of fuel gas: propane, butane, liquefied petroleum gas, which is the same as LPG. If you don't know this, it's fine. Yeah, but all this fuel is because they can produce a lot of heat energy. They can heat up the air quickly. Then the air will become very low dense. Then you can produce a lot of buoyant force. Yeah, material of balloon, you can choose nylon. Most common is nylon actually. Polyester also can. Teacher, I don't know what all these names. Can I just say strong? Can also, no problem. Durable, will not tear, heat resistant, very light. Nylon is very light and very strong. Waterproof also. Okay. What else? Teacher, can I write material of balloon very light, low dense? Can. Low dense, light. Also got mark. Material of balloon is very elastic. Elastic meaning it's very hard to pull. And when you pull, it will go back to original shape and size very fast. The definition of elasticity is talking about the property of a material to go back to original shape and size when you remove a force. When you pull and then you remove the force, you can go back very fast. That's what very elastic means. Meaning it's so strong, so hard to pull, so it won't really stretch. It can maintain shape, very difficult to tear. Or just say, I want a thick balloon. Yeah, can maintain the shape, will not tear also. Size of balloon, big size. See, got so many things to say about the balloon. Can displace a lot of air, displace more air, more buoyant force, produce more resultant force upwards. Material of basket, I choose rattan. Teacher, I don't know rattan. Can I say strong? Can. Yeah. Can I say carbon fiber also, because very light, very strong? Can. Aluminium, aluminium alloy, aluminium or composite carbon, a lot of different ones that you can write. But most common actually is rattan for the basket. I've gone on a hot air balloon before, and the actual basket that they use is really made of rattan. Yeah. And imagine this rattan basket can fit like 30 people in this basket. So it's really, really strong. And we like rattan because it's very, very light. Yeah. So it's a very common material that they use for the basket. Low density, very light, can absorb impact, very strong, durable, can support a lot of load, mass. Okay. Or just say, teacher, what if I just write strong, I write low density? Can. You split up. You get separate marks. Low density, very light. Size of basket, big, can have more capacity, can have more load, more capacity. You try not to say can accommodate more tourists lah. Don't copy the question. You say can have more capacity. Yeah. Additional equipment, we can have some safety cable or ropes. Usually that ropes is to control the balloon, where it move and all. Okay, so sometimes when the wind blow, I need to pull a certain rope so that because maybe the wind blow to the left side, I need to pull the balloon back with some string, some rope. Okay, we also need a parachute valve. A parachute valve is a opening at the top here. Like you can open this valve to let out the hot air. Let's say you want to go down already. Let's say the hot air balloon already end, and then you want to come back down. We need to release some hot air by opening the parachute valve at the top. Okay. To release hot air, to reduce the temperature of air in the balloon, to cool it down. to increase the density of air in the balloon so that it can fall down faster. And one more additional equipment, you can also say at the bottom of the basket, you put some sponge or some cushion or some soft material so that when you land, the impulsive force decrease, the time of impact increase. Yeah, less impulsive force because longer time of impact. And any other logical answers that you think could be written. You see, got so many answers that we can accept. Yeah, it's quite easy to get full marks as long as you don't just write what they say only lah. You can write more things on like anything else other than the material, the basket. You can talk about the size of the balloon, size of the basket. Oh, okay. Anything related to it is fine. Balloon also already got so many points. Strong and light and all. Yeah? Low density. Okay, Ken, that is the end of SPM 2025. Yeah, I'll see you in the next one. Good luck. Huh?